Good morning, everyone. Today we are going to continue with chapter number 5, that is basic behavioral modeling. In last sessions, we have covered use cases, use case diagrams with stereotypes, and interaction diagrams. In interaction diagrams, we have seen sequence and collaboration diagram. Now we will see about activity diagram. In yesterday's session, we have covered that interaction diagrams with example. Interaction diagrams, that is sequence diagram and collaboration diagrams. We have seen the example for both the diagrams. Now in today's sessions, we are going to start activity diagram. Okay. So that activity diagram describes how activities are coordinated between the activities, how activities are coordinated. It is particularly useful when we know that an operation has to achieve a number of different things. We have to achieve number of different things, and we want to model what the essential dependencies between them before we are going to decide in what order to do them. That means, like flow charts, we have to cover some things, we have to perform different things, we have to achieve different things with the output. At that time, we are going to use this activity diagram. So it records the dependencies between the activities, such as which things can be happen in parallel and what must be finished before something else can start. It represents the workflow of the process. In activity diagram, it represents the workflow of the process. Here, activity diagram is used to model the dynamic aspect of a system. At the start of this first sessions, we have seen that dynamic modeling. Okay, so that activity diagram is used to model the dynamic aspect of a system. It is essentially a flow chart. Whenever you are writing any program or designing any software, you have seen that how to draw the flow chart, the syntax of flow charts, the components or the notation or elements of that flow chart. Okay, so activity diagrams are similar like that flow chart. It shows flow of control from activity to activity, from one activity to another activity. It shows the flow of that control, how control moves from one activity to another. So what is the purpose of that activity diagram? It model business workflows and model operations. Then activity diagrams commonly contain some activity states, then action states, transitions, and objects. So when to use that activity diagrams? So the main reason to use that activity diagram is to model the workflow behind the system being designed. The main reason is to use activity diagram is to model the workflow behind the system is being modeled. Activity diagrams are also useful for analyzing the use cases by describing what actions need to take place and when they should occur. Analyzing a use case by describing what actions needed to take place and when they should occur. Based on the use cases, we are designing that activity. It describes a complicated sequential algorithm. That activity diagrams are useful for describing a complicated sequential algorithm so that we can easily understand about that process or that algorithm. It also useful for modeling applications with parallel process. So here you can say that application diagram should not take the place of interaction diagram and state diagrams. All these are different. So activity diagrams do not give details about how objects behave or how objects collaborate. Okay. So through activity diagram, we just know or we just come to know that how that system, what is the flow of that system, how that system move from one activity to another activity. Then how to draw an activity diagram. Diagrams are read from top to bottom and have some branches, forks, to describe conditions and parallel activities. There are some notations while designing or drawing that activity diagram. The first one is like initial node, end node, activity, then flow. There may be a questions for 1 mark in your exam like define fork, define joining, then give some examples like draw an activity diagram that shows decision, conditions, and merge. Okay. So here, how to draw an activity diagram. So for that, there are some elements. Here, a fork. Fork is used when multiple activities are occurring at the same time. Fork means multiple. Whenever multiple activities are occurring at the same time, that means from one activity we are going to distribute number of activities or more than one activity. Okay, so that means it is a one entry transition that denotes the beginning of parallel activities. It is denoted by a thick black bar with one flow entering into it and several leaving it. Okay, so we will see the notation for fork also. Then branch. Branch describes what activities will take place based on a set of conditions. Based on set of conditions. Then all branches at some point are followed by a merge here. All branches at some point are followed by a merge to indicate the end of the conditional behavior started by the branch. Then after the merge, all the parallel activities must be combined by a join. Like fork, we have a join that will join that fork. Okay. So after merging all the parallel activities must be combined by a join before transitioning into the final activity state. So here we will see some notations for activity diagram. Here first notation is see how that activities are represented inside this rounded rectangle here. Here you can see activity 1, activity 2. Okay, these are the activities, and the connection between these is like this arrowhead indicates the transition. Okay, so this is the transition between these two activities, and these two activities are mentioned or rendered in the rounded rectangles. Okay, so this is the notation for activity, and this is the transition. Okay, then second notation is decision diamond. So whenever we are having any activity, whenever we are having any activity, whenever we are having any activity like it's having some conditional box. So for decision at that time we can use the decision box here, like decision diamond. Here you can see decision diamond. Okay, it produces some result. If that condition is satisfied, it will move further, or it will directly go to that end of that activity, or it will go back to previous activity. Okay, so this is the notation for decision diamond or condition box here. Then third notation, here you can see synchronous bar. Here, this is thin bar here, you can see. This is for fork. Okay, sorry, this is for join. Here you can see, this is the example of fork. Fork, splitting bar here. Based on one activity, it produces two output. Okay, two conditions here. From one input, it will produces two outputs. With that, see this thin line. Okay, this is the example for fork, notation for fork, and this is for join. After forking, we can join again all these two output of previous forking. It will join in one. Okay, this is the join and this is the fork. Like and, here you can see and, or, and XOR. We can use also that and, or, and XOR. Okay, so this is the notation for fork and join. Then next notation is starting of the activity and stop. Here, this is the initial node and this is the end node. Okay, with this initial node, we can start that activity. That is, it is filled in circle, filled circle. Okay, this is the starting point that indicates the beginning of the sequence of activities. This is starting point that indicates the beginning of the activities, and this is end node. Okay, it is filled circle with the border around here, filled circle with the border around. Okay, An activity diagram can have zero or more activity, or this is called as a final nodes. Okay, so this is the third notation for start and stop markers. Then this is the fourth one notation. Okay, this is the swim lane. Like these are the applications. Okay, application, department, group role, boundaries. Okay, so these are called as swim lane. Developers, testers, markers. These are the swim lanes. In that, inside that, we are going to draw some activities. Okay, these are the swim lanes. In your books, you can see that swim lanes. Whenever we are going to design any, give any, here you can see one conditional box. We have seen that after that condition is satisfied, we are going to merge that. Okay, this is also notation for merging. Okay, so this is for swim lanes. Okay, there may be a question in your exam like define swim lanes, that how to partition the activities in activity diagrams. So we are going to partition here this activity diagrams. Okay, so swim lanes means the contents of an activity diagram that may be organized into partitions using solid vertical or horizontal lines. Okay, solid vertical or horizontal lines, that is called as swim lanes. Okay, these are the swim lanes. So that activity diagrams are divided here, or that partitions for that activity diagram. This is called as swim lanes. Then here you can see the example for activity diagram. Here see the start node, start state of the activity. Then this is the activity, how activity is represented. Okay, then here you can see the fork. Okay, receive order. After receiving order, that order may be, after, for that order, receiving order, we are going to fork that. That means it will create two sub commands, two sub activities for receive order. It will fill the order and send invoice. Okay, so this is fork. This is the activity, this is the start state. And fill order, here you can see fill order is now branching here. See the decision box, fill order. If that order is rush order, then overnight delivery, or otherwise else regular delivery. After that, we are going to merge that. Here, how to merge that? Here you can see. We are going to merge that branching. Okay. And at send invoice, we are going to at the end, we are going to join this, join the result of that receive payment and this merge. Okay, so at the end, we are going to join and close the order. And this is notation for end the state. This is a simple example for activity diagram having start state, activity, then fork, branching, then merging and join and end state. These are, this example is for that notations. Okay, these all are the notations for activity diagrams. Okay, so we have seen the activity diagrams, notations for activity diagrams, then example for activity diagram. Okay, for the order management example. Okay, we have seen one example for order management. Okay, then next one is state diagrams. State diagrams. In your books for activity diagrams, there are several examples are given. Okay, so please refer these examples. We have taken only one example here. The next diagram is state diagram. So state diagram gives a dynamic view of a system which shows the changing state of the object it goes through in the system. That state diagrams are also called as state chart diagrams. Okay, so that state diagram also called as state chart diagrams. It describes all the possible states an object can assume and how the object states changes as a result of events that affect the object. That object state change from one state to another state, so it will affect on the object, or that events will affect that object. So state diagrams are drawn for a single class to show the lifetime behavior of that single object. State diagrams are good for describing the behavior of an object across several use cases. These diagrams are good for describing the behavior of an object. That object may be a person. Then in the form of use case, it may be a actor. Okay, that real time entity. In UML, that state diagram support superstates. Superstate means state which contain other states. We will see in that example what is superstate. Okay, so state diagram supports superstate and it supports concurrencies. So that while designing a state diagram, it also having initial state and end state. Okay, the notation are similar like activity diagram for initial state and end state. Okay, then state is denoted by rounded rectangle and compartments within to describe the state name, variables and activities. That is state. It is represented in or it is denoted by a rounded rectangle having state name, variable and activities. It represents the state of object at the instance of time. Okay, here see you can see the notations for state diagrams. State diagram also contains the transition with event or condition or actions. It is a change from one state to another. It is denoted by arrow. Here you can see this is the transition between the two states. Okay, here you can see the start of state, that is initial node, initial state, and this is the end state. Okay, then here you can see the concurrent state, that is super state name here. Super state, that means super state contains state which contains other states. Okay, here it's also the state diagram contains the actions. Actions means processes associated with transitions that occurs quickly and are not interruptible. Okay, these are the actions. Here actions. Then activities, these are the activities. Activities means processes associated with states that may take a while and may be interrupted by events. These activities are interrupted by some events here. If that event occurs, it will process with that events. That events may be a stimulus that causes a transition or a self transition. Okay, self transition to take place from one state to another state. Then it also contain guards. Guards means a logical conditions. If that condition may be logical, okay, logical condition that returns true or false. Then super state. Here, super state means a state that itself a collection of states. Super state having multiple states. It is a collection of states. Yes, you can see the initial state, end state, super state, then transitions. Yes, transitions having event, then arguments and conditions or actions. That state consists of, or it is rendered as or denoted by a rounded rectangle. It consists of state name, then variable and the activities. Okay, this is the notation for state diagrams. Then here you can see the notations for state diagrams with example. Here you can see this is the start of the state. It get the first item. It will, here you can see the state name is checking. So what is the activity here? Do check the item. Okay, how you can write the activity like do check the items. We are going to check the items. Okay, here see the transitions for one state to another state, that is all items check and see the logical and all items are available. This is the event or the conditions. This is the transition. Then next activity is dispatching. It contains the activity do initiate delivery. Okay, then it will deliver. See the next state is delivered. See the transition delivered. This is the activities. Okay, these are the activities. And see the transition, these are the transitions. Okay, this is the self transition. Here you can see self transition. When not all items are checked, then get the next item. This is the self transition here. Okay, and then here you can see waiting state is there. It's having also self transition. That means if item received and some items are not in stock, that time it will wait for some time. That is self transition. Then after checking, it will check for all items check and some items are not in stock, then it will wait. Okay, it will in waiting state. And here you can see after waiting, if item received, that means all items are available. This is the condition. Then it will dispatch the order. Okay, so this is the simple diagram for state diagrams. Okay, with the notation start. Okay, at the end here you can give the end state here. Okay, here another example is for a state transition diagram. Here you can see here initial state, here cursor to ssn, here getting ssn, here you can see the events, guards and activities. Okay, here this is the end state, or here final state. Okay, multiple final state, because if that there may be a reject, then it will stop that state. Okay, here you can see if the cursor and ssn, for getting that cursor, after getting that cursor it will getting the pin. This is the another state. Here you can see the event getting ssn. This is the self transition. Press key, this is the event. Okay, press key is event, and here you can see the guard condition, that is key is not equals to tab. Okay, then perform the activity like display key. This is the conditions while transit with that transition. Transition contains event, here event, then condition and action. Okay, so that self transition contains that event like press key, condition like guard, key is not equals to tab, and with action, that is display the key. If it satisfies, then it will move further like getting pin to another state, that is press shift tab or move cursor to ssn field and perform the activity like cursor to ssn. It will revert back to that getting ssn like press tab or move cursor to pin field, move cursor to pin field or cursor to pin. Okay, for getting the pin. If while we are in getting pin state, it's having the self transition like press key event. If that key is not equals to shift tab, that is this is the condition or guard, and activity is display dot. Okay, after submitting, submit transition, here you can see after submitting it will validate, validating state. Okay, do validate ssn and pin, this is the action. Okay, and at the end, if it is valid, then start the transaction, and this is the final state. In between this, if it reject, that is not valid, or if it display the error message, it will reject that pin or application here, and cancel the, or this is the action for the state. It will cancel or quit and end the state. Okay, so this is the simple example for state transition diagram. Okay, so in this way we have finished with chapter number 5, that we have seen activity diagram and state chart diagrams. We have seen some examples for activity diagram and state chart diagram. In your books, there are multiple examples are given that are asked in your exam, like draw state diagram for stack operations, for restaurant management system. Okay, so kindly refer these examples. So we will stop here. We will finish. Sorry, we have finished the chapter number 5 here. Thank you.